Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You begin by listing every force on the object and drawing a clear free body diagram. This makes invisible influences visible. Once done, pick a coordinate system. Align an axis with the motion to simplify components. Make sure to mark magnitudes and directions, and note any angled forces so you can resolve them next. Don't delay. Accurate identification and a neat diagram cut down errors in later algebra and prevent misapplied signs or missing contributions. You now resolve any angled forces into components using sine and cosine, labeling x and y contributions. This lets you add like terms. Once components are written, apply Newton's second law separately to each axis. Sum of forces equals mass times acceleration. Make sure to include frictional and normal forces with correct signs and substitute known values. If acceleration is unknown, keep symbolically until you combine axes and simplify terms before solving to avoid algebra mistakes. You finish by summing components to get the net force vector, sigma fx and sigma fy, then calculate magnitude via the Pythagorean relation. Compute direction with arctan if required. Once solved, double-check units and sign conventions to confirm results make physical sense. If numbers look off, recheck component signs and any omitted forces. Troubleshooting tip: if acceleration or magnitude seems wrong, revisit the free body diagram and axis choice. Most errors stem from a missing force.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.